direction signals to the rover, and then that gives you better accuracy. Very expensive, $35,000 to $50,000, still somewhat in that price range for good stuff. You have to have line of sight from your base station to your rover, but the accuracies you can get less than an inch, and that's kind of what the survey grade type of accuracies are. A lot of the survey grade accuracies give you this accuracy or better accuracy if you set up at a static location. And when you're surveying, a lot of people will go to a certain mark, they'll set up this pole that has this receiver on it, and they sit there for 5 to 10 seconds. And it's called an epoch. It's a duration of which you're sitting there, you're calculating that static position over a period of time. Here, we're not doing static positioning. We're doing on-the-go types of accuracy. Which kind of bothers me because their static accuracy here and their pass-to-pass accuracy are the same, but where over here they're not. But anyway, this is very accurate types of positioning, but it's very expensive. And this would only be for high dollar crops, high value crops.
So that is really expensive, but isn't that the price of just like one worker?
For a year,
Right.
yeah, yes.
So for one harvest season, I mean, you already save money by getting, I mean, if it's a large enough field.
Yes, and that's true. That is pretty good high price for a person for a year, and typically most farm workers don't work a whole year. The situation, though, like I said, in California, is that they made a law where you have to have somebody in the tractor seat. So you really don't have anybody out there. Now they could be doing other work. I don't know if they're doing other work or not, but it's a safety concern. You know, all of a sudden you're out there and there's a cow running across the field. You're not going to just run over that thing, or you're going to run off in the field, or there's people, you know, in the field. So it's more of a safety issue than a workload type of issue. Don't know. I mean, I would think that it would be, unless I've got a very high dollar crop and I want to make sure that I'm doing not really, spraying is not that important, but the cultivation, I think, is important, is where a lot of these units are being used, where they're trying to cultivate real close to the crop row and plant real, a well-defined crop row, and then come back and cultivate that crop row. And that's where you're seeing a lot of the rate of return on this. It'd be pretty tough for some local farmer to buy a system like this that's putting in corn and soybeans in terms of their margin rate of return. But California, vegetables, strawberries, that's where you see a lot of this type of application. Okay. Now, the other thing I wanted to mention is this is an automation type of protocol. And one of the things in the class that we're in right here deals with production automation and production automation and monitoring. There is some applications, and I try to present to you the technical aspect of the class, the pressures and the flows and the positioning and the GIS. But there's a lot of political aspect to this. And there are some people, especially with this unemployment that we're in right now, concern, is that a lot of the automation that we have, combines, harvesters, whatever, is putting people out of work. And actually the Ag Engineering program out of University of California got their mechanization program shut down by the state of California. This was back in the 70s, because they're basically developing combines and automated harvesting systems. They're going to put the people in the state of California out of work. They're basically going to reduce the amount of labor available on farms, and then these people would have to find jobs somewhere else. So that's an issue here. If we have all of a sudden everything's automated, where are all the workers going to go? We don't need that anymore. And so the concern was, people in the state of California says, this state-funded school is putting our workers out of jobs, and they got their mechanization program shut down for several years because of that, and of course it came back. Because, oh, this is a good thing. But that's, if you automate too much, is that a good thing or a bad thing? Because people are losing jobs because of that. But that's just some of the political aspects of the class. Okay.
That doesn't count illegal immigrants picking
Oh,
up
yeah.
watermelons.
Right. Let's not get into that issue right now. Yeah. There are other applications of this type of technology. I use this when I do underwater video mapping in an ocean. I do coral reef mapping, and when I'm out and I want to do a big area, I set up my light bar on a boat. This is really kind of hard to do. And we drive, and when I set point A, same light bar we use down there, go to a certain GPS location, set point B, and I'm running 20-meter swaths. I can drive my boat around, I come back, line me up on the next swath, and we drop our camera down, and we go to the end of that, tells me where I'm at the end of the swath, take another turn. So I'm doing 20-meter swaths with this unit. So it doesn't necessarily have to be just an agricultural field. This type of application can be useful anywhere. Of course, we talked about aerial application, but anytime you're trying to get a coverage, uniform coverage of a field or a coral reef, then this comes into play. So there are applications elsewhere. Okay, that pretty much covers guidance systems, and what I'm going to move into now, and other than some other things, we're going to move into a project in the class. You've done your variable rate application. We're going to look at soils maps, web soil survey, which we're going to talk about next week, and aerial photographs, how to bring those in, georeference those, and use those. I also want to talk a little bit about literature. And what I mean by literature is there's a lot of units out there. For example, if I'm going to give you this, let's just talk about this right now. Because we're moving away from the land-based stuff to more towards the equipment that does it. I've given you plenty of background, I think, on controllers and yield monitors and things like that. But what's out there that does all this? And so let's talk about this a little bit right now, but in the next lab we're going to be looking at a variety of different equipment descriptions. This is the Orthman GPS system, GPS planter drive. Ooh, that's kind of neat, a GPS planter drive, okay? And what does it do? Well, it's for planting. It's got the adjust-a-rate GPS system, where I can look at the application rate, and the application rate here talks about seeds, a planting population. So you can look at how much I'm putting on in terms of seeds. And how does this actually work? So I've got a hydraulically driven planter drive system. Now, this hydraulically driven system is essentially my actuator. This is the thing that I vary the speed of this planter drive system, and if I increase the speed, it's going to drop more seeds in. If I decrease the speed, it's going to drop less seeds in. So that's how I control this. It's a now available GPS capability. How does that work? How's that planter now available with GPS capability? Well, let's go in and explore that a little bit while we have some time. So, control system features 5 pre-selected population grid capable of plugging into your existing GPS system. How do I plug that into a GPS system? Usually you take a GPS system and plug it into something else. How do I plug this